Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam IFM. Assume the Black-Scholes framework. You are given the following information for a stock that pays dividends continuously at a rate proportional to its price. The current stock price is 0.25. The stock volatility is 0.35. The continuously compounded expected rate of stock price appreciation, just stock price appreciation, not the full return, is 15%. Stock price appreciation does not include the dividend. Total return is derived from both of them. Calculate the upper limit of the 90% log-normal confidence interval for the price of the stock in 6 months. And here's the solution. The conditions and data given are S0 equals 0.25, sigma equals 0.35, alpha minus delta equals 0.15. And alpha is, of course, the rate of total return, continuously compounded. Delta is the dividend yield of the stock, continuously compounded. The random variable, natural logarithm of s at 0.5 over s of 0, which is the natural logarithm of s of 0.5 over 0.25, has a log-normal distribution with mean alpha minus delta minus 1/2 sigma squared times t. In this case, t is 1/2, and all the other data is given above. We plug it in, and that becomes approximately 0.044375. And the standard deviation is sigma times square root of t, so 0.35 times the square root of 0.5. It's approximately 0.2474837. Since the 95th percentile of the standard normal distribution is 1.645, the upper limit of the 90th symmetric confidence interval for the normal random variable, the natural logarithm of s of 0.5 over s of 0 is normal, is the mean plus 1.645 times the standard deviation. And you may say, well, it's a 95th percentile that we're using, but of course, if it's a symmetric confidence interval, then it has 5% at the top and 5% at the bottom. If you take those two out, you're left with 90%. And 95th percentile is the one that shows us that 5% at the top. So this is 0.15 minus 1/2 times 0.35 squared times 0.5 plus 1.645 times 0.35 times the square root of 0.5, and that's approximately 0.45149173. And for the log-normal distribution, log-normal confidence interval refers to log-normal distribution, of course. Trying to emphasize the log-normal confidence interval. Well, what's a log-normal distribution? That's a distribution such that if you take the natural logarithm of a random variable having that distribution, you get a normal random variable. Okay, so that normal random variable is the continuous compounded rate of return, and the log-normal distribution refers to the price of the stock. And the upper limit for the corresponding 90% confidence interval for the stock price S.5 is therefore 0.25, the initial price, times e to the 0.451 49173. That's this 95th percentile that we just found in the previous calculation. And that's approximately 0.3926636. And that's answer A. Please remember this is copyrighted material. The problem comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.